Well, hello and welcome back to math. You will notice I do not have the book in front of us for today. We're going to kind of do something a little bit different to make sure we're understanding what equivalent ratios are. If you have the capabilities to run this off at home and you want to write on it at home, that's fine. If you would rather just write these things on a piece of paper as notes, that would be helpful as well. So we're going to kind of look at some different problems here. You'll notice that it says we're going to write some equivalent ratios at the top. Right, two equivalent ratios. We have a ratio here of 10 to 7. And in order for us to make an equivalent ratio, remember how we kind of would make these arrows and we would multiply by the same thing. Well, let's multiply, for the first one, I'm going to multiply by 2. And if I do that, then I'm going to have a ratio of 20 to 14. I could then also do a different number if I wanted to. I could actually multiply it by 3. And if I did that, then I have a new ratio. 10 times 3 would be 30, and 7 times 3 would be 21. So I have 3 ratios here that are all equivalent. We have 10 to 7 is equivalent to 20 to 14, and 30 to 21. Okay? Let's try another one here. Let's have here 7 to 3. If I wanted to make an equivalent ratio, I could decide to multiply by, I like smaller numbers again, so let's go ahead and multiply by 2 again. And I would have 7 times 2 is 14, and 3 times 2 is 6. So 7 to 3, that ratio is equivalent to 14 to 6. If I wanted to make a new one, I could pick a different number to multiply by, and let's do 4 this time. So 7 times 4 is 28. And 3 times 4 is 12. So once again, I have 3 equivalent ratios. All right, well, something else we're going to review here is I'm going to move down. We'll move down here to problems 7 through 12. Let me move my camera a little bit here. All right, we have to determine whether or not these ratios are equivalent. Well, let's see. If it looks like to me this ratio has the smaller numbers than these, so I'm going to make my arrow. Is there something that I can multiply? 2 times what is 12? I would say 2 times 6. Can 9 times 6 be? Nope, that doesn't work, so I would say these are not equivalent ratios. No. Let's try the next one. Smaller of the two ratios is 5 to 4. Let's see, 5 times what is 15? 5 times 3. 4 times what is 12? 4 times 3. So these would be equivalent ratios, yes. We had the same constant of 3. Let's try the next one over here. Oh, where should we go? Which direction? Well, let's start with this one here. Can I multiply? No, I can't multiply 7 times anything to get 11. And the same here, so I'm going to just say that this is not an equivalent ratio. Let's look at problem number 10. Okay, let's see. 2 times, this doesn't seem to work up here either. How about the bottom? 3, this one doesn't really work either. So I'm going to have to say this is no. Let's go to number 11. Let's see. 11 times 5 is 55. And 8 times 5 is 40. So this is a yes. Eventually, we're going to do something called cross-multiplying with these numbers, which will help a few of you on solving this as well. Let's look at the last one. 4 times 6 is 24. And let's see, hopefully 9 times 6, yes, and that works. So these are equivalent ratios. These are not. These are not. Okay? All right, let's move down to the bottom section of my paper. If I would want to solve equivalent ratio and find the missing number, so I want to find out what y is in order to make this equivalent, I would notice that 11 times 2 is 22. So 8 times 2 would be 16. All right, let's look here. 11 times 3 is 33. So 9 times 3 would be 27. I can't do this one because the end's down here, so let's do this one. Let's start with a smaller number. Looks like 4 times 4 is 16. So 11 times 4 would be 44. All right, can you solve number 16? If you gave me the answer 6, you are correct because 9 times 3 is 27. So 2 times 3 is 6. How about this one? I don't want to look at the denominators because that's what I'm solving. The numerators, let's see. Let's start here at the 3. What can I multiply? Times 5. So I have to do this one times 5. And my answer is 35. Last one. Let's see. 5 times 2. And so that means I want to go 7 times 2. And I have 14. Okay, we have created equivalent ratios. All right, so the last thing I would like to have you guys look at as a review today is reducing ratios. In our videos, we also call that the word finding the value. Okay, finding the value. Well, if you notice, the first example has been done, so I'm going to go ahead and look at number 1. Now, a lot of times when I like to reduce mine, I like to write them as a fraction. You don't have to write it as a fraction. You can leave it as a ratio like that. I need to find a common factor that goes into 24 and 18. This would be a good time for you to pull out your factor sheet if you have one. So, for example, my factor sheet looks similar like this, and I'm looking at, if you recall, we're going to look at 24. My 24 is down here. There's my factors, and then my other number that I was looking at was 18. And there's the factors. To me, the largest number that we have in common is a 6. So that means I'm going to reduce this by the factor of 6. I make a little note here so I can remember what that number is. 6 times what is 24, or 25 over 6? This would be a 4. And let's see, 6, this would be a 3. So my new ratio would be 4 to 3. And I would leave it in the same order. I don't want to flop it because remember, switching ratios, these would not be equivalent anymore. Let's try this 4 and 10. 4 and 10. Well, let's see. 4 and 10. I know that they are both even, so I could divide by 2, which would give me 2 and 5. So my equivalent ratio would be 2 to 5. Now, if I wanted to, I could also write the ratio like this: 4 to 10 and 2 to 5. I could check it. Remember, we go first one to first. 2 times 2 is 4, and 5 times 2 is 10. Okay. Let's try a couple more of these, and then I'm going to have you guys practice this. We have 20 and 32. Oops, 20 and 32. I need to find the largest common factor. Once again, if you need to look back at your factor sheet, please do that. I think the largest factor is going to be a 4. 4 times 5 is 20, and 4 times 8 would be 32. So my value of 20 to 32 is 5 to 8. Okay, let's try one more. Well, let's say I don't have a factor sheet and I want to try and solve this a different way. Well, factor sheets are going to be the easiest and quickest way, but let's say, for example, I know that both of these numbers are even. It's going to take me a little bit longer, but I know since they're both even, I could divide them both by 2. So I'm going to have 20. And if I take 56 and I divide it by 2, then I have 28. Oh, I'm still even again, so now I need to divide it by 2 again. 20 divided by 2 is 10. 28 divided by 2 is 14. Oh, look at this. They're still even. I can keep going. Let's see. 10 divided by 2 is 5. And 14 divided by 2 is 7. So it looks like I finally got the answer of 5 to 7. Now, if I would have done that a quicker way, I would have found out from my factor sheet that both 40 and 56 can be divisible by 8. 40 divided by 8 is 5, and 56 divided by 8 is 7. I still got the same answer, but I just did it a different way. Okay, that's what the nice thing about math is. There's lots of ways to solve problems that you can still get the correct answer, but it depends upon what you are comfortable with. Okay, so for today we were just reviewing what equivalent ratios are. You should have a Google Doc or Google form for you to fill in for practice.